Hey Amber, you said in your email that you could get to a point where you had something that looks like this, and then you just fill in the rest of the numbers. So I'll just make some things up. 3, 4, 2, 1, 5, -3. Okay, so let's say you worked the problem out and you got into this situation right here. This is actually fantastic. You pretty much have all the work finished at this point. All you have to do is kind of rewrite what these equations mean. And what these equations mean are the following. X plus 3y plus 4z equals 1. That's the first row. The second row tells you that y plus 2z equals 5. And the third row tells you that z equals -3. So if this is the situation that you're in, then you already have z. You figured out what z is. Z already equals -3. So that's great. Z equals -3. Now, if you want to find y, what you do is you take the second equation and you solve for y. You say, okay, well, y is, you subtract 2z from both sides, you get -2z plus 5. You know that z equals -3, so all you have to do is plug it in. Oops. All you have to do is replace z with a -3, and that's going to give you y equals, what is that? It's +6 plus 5, that's y equals 11. So we have now z equals -3, and we have y equals 11. How do we find x? Well, we keep moving back up the equations here. This first equation tells us that x equals -3y plus 4z plus 1. Oops, I'm sorry, minus 4z. So all we did there was we subtracted 3y and we subtracted 4z from both sides of the equation to solve for x. Now we can plug in what y is. Y we know is 11. And z, which is -3. And if I can just squeeze it in here, let's see, that's going to be -33 plus 12 plus 1. I believe, if I'm not mistaken, that's a -20. You'll want to check me on that. But those are our three equations. I mean, those are our three answers. X equals -20, y equals 11, and z equals -3. If you got yourself down into this kind of a situation right here, that's how you finish off the problem. My guess, though, is that you may have run into a slightly harder problem. So I'm going to do a different one for you, too. So this problem is the one that you sent me right here. And I turned it into a matrix system here. And I skipped a lot of steps, so you probably don't want to try to follow my work. But I got it down to this matrix right here. And I think this is what's causing the biggest problem. Because when we look at this, if we rewrite every one of these equations, we get something that ends up being kind of funny. So the last equation just completely disappears. You get 0 equals 0, which of course is true, but it's not necessarily helpful. So when you get a situation like this, where you have 3 unknowns and only 2 equations, you have fewer equations than you have unknowns. This is a case where you have infinitely many solutions. The question is, and I think the most confusing part is, how do you actually write that out? And what the computer suggests is you take this equation here and you solve it for y. So I'm going to do that. You get y equals +4z minus 3. Then what we can do is we can take this first equation and solve it for x. That's going to be, I'll do it in 2 steps. -x plus, -x equals -y minus z minus 1. And if you want to get x by itself, you divide through by a -1, and all of those negatives go away. You get y plus z plus 1. Okay, so far what have we done? We solved an equation for y. We're going to use that in a minute. And we solved an equation for x. The goal of this is really to get all of your variables, x, y, and z, only in terms of z. So you have a y here, and the only variable on the other side of the equation is a z. You have an x here, and you want the only variable on this side of the equation to be a z. You have a y though. So what do we do with it? Well, what we do is we take our value for y that we found right here, and you plug it in. So that's going to give us x equals y, which is now 4z minus 3, plus z plus 1. Now we can combine terms. We get x equals, let's see, that's going to be 5z minus 2. And that is going to be another equation that we're going to use. So if we want to write out what our answer is, what we do is we say, okay, our answer is going to be written in the form x, y, z. That's how they do it in MyMathLab. Well, what is x? Okay, x is 5z minus 2. What is y? Y is 4z minus 3. And what is z? Well, z is just z. So the answer that they want, I believe, is going to look something like that. Of course, there is a point where you have to say that there are infinitely many solutions as well. Basically, what is this telling us, I guess is the question. We can plug in any z value we want. We could pick any number for z. Say we chose z equals 1. If we chose z equals 1, then we would get a point, z equals 1. This middle section here is y, and we would end up getting, let's see, z is 1, so you get 4 times 1 minus 3, that's 1. And this first section here is representing x. If we plugged in z equals 1, you get 5 times 1 minus 2, that's 3. So that is a solution. And we got that by plugging in z equals 1. However, we could pick any z we want. I'll do one more example. You could pick z equals 2. And let's see, z equals 2. 4 times 2 minus 3 is 5. If I plugged in z equals 2 here, you get 5 times 2 minus 2 equals 8. That is a solution as well. So no matter what z you pick, you're going to get a different solution here. That is why the answer is we have infinitely many solutions to this problem. Because we can pick any z we want now, and you get all kinds of different solutions. This is the way that we denote this mathematically. It's, I guess it's just the simplest way to write it, all in terms of one variable, which we chose to be z. Okay, I know that's confusing, but I hope it helps. Let me know if you have any questions.